Hi everyone, welcome to the next video in the Wide Assurance series. What we wanted to show you now is a worked example of how to actually put together all the elements that have previously been demonstrated. If you refer to the on-screen diagram, what we're going to now configure using Wide Assurance is a pair of collapse core switches. These are EX4650s and a set of access switches, and I'm going to use an example of both a virtual chassis stack and a standalone EX switch. Okay, let's get going. First off, let's dive into creating a switch template. You can do that by going into the organization part of the menu and then clicking on switch templates. I've actually already got a template ready that I want to show you, so I'm just going to click straight in here. First off, let's give this template a name. Here you can see I've just called it campus template. Templates are actually broken down into three sections by which you can apply configuration to all switches, shared between switches, and only to individual switches. Let's start though on all switches. First off, I'm going to set my Radius server IP addresses along with the timeout values. I also have an NTP server, which I set here. Finally, in the CLI configuration box, include any common elements of configuration that you need to apply to all switches. The next step in the template configuration is to define the networks and port profiles. So first, just looking quickly at this slide, these are the VLANs that I'm going to define in the network section. We basically have a VLAN for each of the service types. So we have our corporate users, guest users, IoT devices, and cameras. We also use a default VLAN for in-band management, and we have a special VLAN, which I'm numbering as 99, as a restricted use VLAN, which we'll use for the dynamic port profile configuration. With the dynamic port profile configuration, the VLAN 99 will effectively mean that the traffic has no route to anywhere unless then the switch detects through the dynamic port profile configuration a specific device that then can be remapped to a specific VLAN, for example, a wireless access point or camera or IoT device. Okay, so going back to the portal, if we go into shared elements and we look at the network section, this is where we define the VLANs that I listed in the slide. You just need to click the add network button, enter a name and a VLAN ID. Okay, now let's define some port profiles. Just referring to a slide for a moment, what we have here are 8 different profiles, each which define a mapping between the relevant VLANs and the type of port on the switch. Okay, back to the MIST portal, looking at the port profile section, fairly simple to add, just click add profile, you need to give it a name, and then we can set the parameters for the kind of port that we're describing, so whether it's trunk port or an access port, the associated VLANs, whether it's a voice port. For a trunk port, you can actually set the untagged or native VLAN. And then down here, you can actually tag in either all networks or specific networks that you want to be a member of the trunk. Then you have other parameters like speed, duplex, whether it's a PoE port. Let's have a quick look at a profile I've already defined. This is one for the cameras. So this is an access port. I'm adding it to the camera VLAN. And there are no other special parameters to set for this one. And now if I look at my switch uplink port, this is actually going to be defined as a trunk. I'm using VLAN 1 as the untagged, and then tagging in all of the defined VLANs that I require. The no access profile is specifically for using with the dynamic port configuration. So this one sets the VLAN to the no access VLAN as the default for that port. And now let's build the logic to actually build that dynamic port configuration. Let's have a look at my existing rule here. What I'm actually going to do is match on the LLDP chassis ID, which is basically the MAC address, and then apply the configuration profile of Wi-Fi AP. With this then, as soon as the switch detects a new connection matching that MAC address string, this switch will then dynamically apply a new profile. The next step is to look at the select switches configuration for the different switch types that we have in the topology. Before we do that, a quick reference of the port mappings for what we're going to do on the distribution switch. Distribution switch is actually a virtual chassis, so we've actually got the members 0 and 1. We're going to configure ports 4, 5, and 6 on both members to face towards the access switch. And we're going to use port 0 on both members to face the WAN router. In this case, it's an SRX. Okay, if we hop back into the UI and select switches configuration, the first step would actually be to click add rule, but I've actually got some set up here. But what you do is you give it a name and you define a role that you want to apply it to. You then define each of your ports and the profiles to those ports. Let's have a look at how these are configured. So you specify the port range that you wish to apply the configuration profile to, and as these are actually going to be lag interfaces in most cases, you tick the port aggregation box. If you need to include any special configuration for that device type, go into CLI config and you can paste that in here. Okay, so that's the select configuration complete for the distribution switch. Let's look at the access switches. Let's just have a quick review of the port mappings again for the access switches. What we're looking to do here is to simply predefine some port ranges that can be applied across all switches so that the rollout is highly templatized, therefore any new switches added into the environment later will just simply inherit the same configuration. For my topology, I'm going to create two more select switch configuration profiles. Here I've got my standalone switch configuration profile defining my port ranges to port profile mappings. And now for my two-member virtual chassis, same again as all the other switches, define the port ranges, mapping those to the configuration profiles. On the switch uplinks specifically, do remember to tick the port aggregation box as these will be lags facing the distribution layer. And for the ports that we want to apply dynamic configuration to, ensure to tick the enable dynamic configuration box. This then will pull in the configuration previously applied where we match on the MAC address. Okay, great. So that's our campus template finished. Remember to click save when you're done at the end of this stage. What we need to do now is actually onboard the switches. So if we navigate into organization and inventory, then to switches, as we're using a brownfield method here, we're going to use the adopt switches process. Simply copy the adoption text and paste it into your terminal on the switch. The device will then begin to onboard in the background after you've done a commit. Your switch will then appear in the inventory list with a grey icon. I'm using an existing switch here, but what you do is you need to tick the box and then click assign to site. I'm assuming you've already got a site created, but if not, navigate to organization and sites. You can click create site and define all the parameters in here. Okay, carrying on with the onboarding, let's work on the distribution switch first. Make sure we set a host name, but then let's actually look what happens with inheriting config from the template. So without the role specified, we don't pull in any of the select switches configuration. If you type in the role name L2dist here, like we defined in the template, the switch then inherits all the configuration for the ports and any other role-based CLI commands that were in the additional settings within the select switches configuration. Now let's look at the other configuration elements pulled through from the template. First, we're inheriting the dynamic port configuration, the port profiles, and all the VLANs. The main point to stress here is that you've not had to do any of this manually. It's all been inherited from the predefined template. Okay, this switch is done. It's inherited all the config we need. Let's click save. What we now need to do is repeat this same workflow for the access switches, just taking a quick walkthrough of each switch then. Make sure you applied a name and a role so that the switch inherits all of its necessary configuration. This site fully onboarded, let's have a look at some of the in-life management features. Let's go into the topology view. Here you can expand all the way through from the edge SRX through the distribution switch into each access switch and to your devices beyond, including any access points. Just like in the list view, in the topology view, you can actually click through to the switches. So let's have a look at the distribution switch. If we look at the ports, you can see that each of the link aggregation group members are color-coded across the virtual chassis so that you can easily identify a pair. You can also see that the dedicated virtual chassis ports are labeled with the primary and secondary members. If we also check each of the access switches, you'll see that the uplinks are clearly labeled and similarly color-coded where they are lagged together. Earlier in this video, we configured a dynamic port configuration. If we look at access switch 86 specifically, I have a Wi-Fi access point here. You can see that this port is actually configured as the no access port. So without the dynamic profile, this isn't going anywhere. Now, as I've just reconnected this access point, what we'll actually see is the dynamic port profile in action. You can see from the timeline that when I disconnected the access point, the port profile was set to the no access default. However, when I reconnected the access point, the profile then changes to Wi-Fi AP and it inherits the relevant configuration. I hope this video has been helpful in showing you how to build a medium campus using MIST Wide Assurance. For a deeper dive into each of MIST features, please do check back over the Wide Assurance series playlist. Thank you very much for listening.